7.3, proving a quad is a parallelogram. Essential question, how can you prove that a quad is a parallelogram? Let's go back to the definition. A parallelogram if and only if both pairs of opposite sides are parallel. In this lesson, we're going to be taking a look at what do we need to see in order to conclude that it's a parallelogram. With the definition, if we can see both pairs of opposite sides parallel, then we can say it's a parallelogram. We're going to have some theorems that will also help us prove that it's a parallelogram, and these will be converses of the theorems that we've had before. If we can prove that both pairs of opposite sides are congruent, then we're going to be able to say it's a parallelogram. If we can say that both pairs of opposite angles are congruent, then we're going to be able to say that it is a parallelogram. Let's take a look at a proof. In this proof, we're showing that both pair of opposite sides are congruent. We're going to draw a diagonal through any 2 points that exist exactly one line, and this diagonal is going to be reflexive. We're going to be able to get the two triangles congruent by SSS. Now once the triangles are congruent, we'll be able to say that this angle right here is congruent to this angle, and this angle right here is congruent to this angle because of CPCTC. Now these happen to be alternate interior angles that are congruent, which allow us to say that these lines are parallel. And if we can show that opposite sides are parallel, the definition says it's a parallelogram. Let's take a look at this diagram and explain if we can say that it's explain why the moving platform is always parallel to the ground. And the reason why it has to stay that way is because it always maintains its shape of a parallelogram. Because if both pairs of opposite sides are congruent, then it's a parallelogram. Okay, you try this problem. Go ahead and try to find the fourth angle, and once you find the fourth angle, decide if this is a parallelogram. Here's the answer. I found the fourth angle, knowing that a quad, the sum of the angles of a quad is 360, so that last angle must be 138, which shows that it's going to be a parallelogram because if both pairs of opposite sides are congruent, then it's a parallelogram. For what values of x and y is this quad a parallelogram? Well, since I'm working with sides, I want to show that both pairs of opposite sides are congruent. So I want to set these two equal, and when I do that, I am going to get x is equal to 10. So that's one of my requirements, that x is equal to 10. And if x is going to be equal to 10, I'm going to put 10 over here, and y will have to be 17. When x is 10 and y is 17, then opposite sides are going to be forced to be congruent. Here are some more theorems that will help us prove something's a parallelogram. This one is not a converse. Let's take a look. It says one pair. Most of the time we were saying both pairs. One pair of opposite sides are congruent and parallel. We can say this is a parallelogram. So if you can see this kind of situation, then we can say it's a parallelogram. And this is also a converse. If the diagonals bisect each other, then we can say it's a parallelogram. Okay, this doorway is part of a building, and we want to explain how we know SV is equal to TU. Now I see one pair of sides that is parallel and congruent. So I can state that this is a parallelogram because if one pair of opposite sides are parallel and congruent, then it's a parallelogram. Now once the triangle's been established, once the figure has been established to be a parallelogram, I know that this side is congruent to this side because if you have a parallelogram, then opposite sides are congruent. All right, for what value of x is this quad going to be a parallelogram? Now the theorem I want to force on this is if the diagonals bisect each other, then it's a parallelogram. So I want to force these to be equal. So this will be 2x is equal to 8 and x is equal to 4. Your turn. Try to find the values of x and y that'll force this to be a parallelogram. Here's the answer. You want to use the theorem if both pairs of opposite angles are congruent, then it's a parallelogram. So you want to force these two angles to be congruent to each other and these two angles to be congruent to each other. And that'll be 32 and 29. State the theorem that you can use to show that the quad is a parallelogram. Stop the screencast and see if you can state the theorem. Here are the theorems. I want to make sure that you do give me the complete theorem with all the important parts to it. Don't forget this word both when we're referring to more than one pair. Your turn again. And here's the theorem that you want to use. If diagonals bisect each other, then it's a parallelogram. So you want to force this to be congruent to this. Okay, let's do a coordinate proof. We want to show that this is a parallelogram, and I'm going to look at slopes here. So I'm going to find the slope of AB, and this looks like its rise is 2 and run is 1, 2, 3, 4, 5. Now I'm going to find the slope of DC up 2 and then over 5. Now since these slopes are the same, then this tells me that segment AB is parallel to segment DC, because if slopes are the same, then they're parallel lines. Now let's take a look at AD. AD is down 1, 2, 3, and then over 1, 2, 3. So it's down 3 over 3, which is negative 1. I want to do the same thing for BC. I want to go 1, 2, 3, 1, 2, 3. So negative 3 over 3, which is negative 1. Now this tells me that segment AD is parallel to BC. So I've shown two sets of parallel sides, so if both pairs of opposite sides are parallel, then it's a parallelogram. All right, your turn to show me whether this is a parallelogram or not. Okay, here's the answer. You may have used the slopes like I did, but I want to show you some other methods that you could use. One method you could use is to find the slopes of just two sides. So for this particular problem, I am going to only work with side KL and JM. I'm going to find its slope, and I'm going to notice that these are parallel. And then I'm going to find the distance, and I'm going to find that they're congruent. And therefore I can say if one pair of opposite sides are parallel and congruent, then it's a parallelogram. Another way, those of you who like the distance formula could use the distance formula like I did just before that, and then use the distance formula on these two, and then you can use the theorem if both pairs of opposite sides are congruent, then it's a parallelogram. So you really have three methods. Method 1, using the slope. Method 2, to use slope and distance. And method 3, to just use distance. Now this is a summary of all the ways you have to prove that a quad is a parallelogram. And remember that this is the one right here that is not a converse. All the others are converse or come from the definition.